Hello guys, I'm going to be showing you an astonishing experiment today with a straw, some Play-Doh, a bowl of cold water, a Coke bottle, and a measuring cup that's going to be filled with hot water.
Go.
I'm taking this hot water and I'm going to put it in this bottle without burning my hands off. Oh boy, I'm scared. Okay, so now it's full. I'm going to let it sit for a couple seconds. This is really, really hot. Dumping it. Oh. Putting that down. Hot. Take this Play-Doh. Take the straw. Take the Play-Doh first, actually. See it? Roll it out like this. Take the straw. Roll up. Roll up. It's actually kind of sloppy, but I think that should do. Just make it tight enough to seal the opening of the bottle. Okay. Finally put it on top of the bottle. Yes. Make sure you don't leave any openings. Otherwise it won't work as beautifully as I want it to. Put it on top. And just watch the ratchet happen in a couple seconds. Maybe a little bit more than a couple seconds. Oh my gosh. Look at that. It's coming out of the straw. See how it's rising a little bit right here? Give it a minute for you guys to see. See how it's just slowly rising. Well, now you may think in your mind, well, how did you do that? Well, I'm going to start off by explaining the formula for pressure through the liquid, which equals the weight density times depth. And the density of fresh water, which I use for the bowl, is 1,000 kilograms per meter cubed. And plus the depth of the bottle, it's also greater than the bowl. So there's going to be water pressure involved with the water getting from the bowl to the bottle. Now you may be thinking, well, how does the water from the bowl transport to the water or to the straw to the bottle? Well, two things. First, when I seal off the opening of the bottle with a Play-Doh, it's making the air inside very, very tight. So all the air pressure inside is forcing the water to come up. Plus, also gravitational force is also cut off from the outside of the bottle, which gravity normally, makes the water into like a puddle, downward slope, how it's kind of like spread out. And when it's cut off like that, it allows the water to flow upwards instead of downwards. Now, second, as that hot air inside is cooling down, the pressure also cools down too, which creates like a vacuum, and it sucks up the water from the bottle, or from the bowl of water. Now, to explain this in further detail, in case if you still confused or if you still have questions in your head, as temperature increases in very confined spaces, such as bottles, for example, as the temperature increases, the pressure also increases, and if the temperature decreases, so does the pressure. Now, what I mean by sucking up, like it's sucking up the water, the pressure, or like acting as a vacuum, that's not what it's actually doing. What it's actually doing is the pressure or the force of the air pressure going through the straw is so great because of the very small area the straw takes up. According to Pascal's principle, force equals pressure times area. It's while the air pressure is going down the straw, water and pushing on the water pressure is coming up through the straw, so it's kind of acting like whoosh, you know. Why I chose this project is because it's very entertaining, in my opinion. It was one of the only ones that I actually found entertaining to do, and because it leaves a perspective in people's mind, like, wow, or how did you do that? Like, and I'm happy to explain it.